Hello, good morning everyone. Can you hear me properly? Okay, fine. So let me first share my screen and then start discussing. Okay, I think you can see my screen as well. We define what do I mean by big O of some function. So this is just to remind you, this is a notation that we'll be consistently using for describing the upper bound of running time. And we mentioned this as well, like this is the hierarchy that will follow, which is indeed the case. So our goal always will be to solve some problem with as less running time as possible. So it will be better for us if we can solve it. Most likely this constant is not possible, but as close as we can get, that will be good for us. And also we define this other notation like big omega of some function, big omega of some function, and this is for the lower bound of the problems. Right? So if I say that for certain problem, uh, its running time should be omega of log n, that means that that problem cannot be solved better than log n. And if it is the case that we have both upper bound and lower bound with the same function, like this is the upper bound and the lower bound, then we'll say Tn is basically theta of fn. And those things we discussed last time. And also we continued with the running time analysis of insertion sort. And in tutorial class, selection sort and bubble sort were discussed. So I'm not going to discuss those selection sort and bubble sort, but today what we do, we'll see another sorting algorithm, and that algorithm will be different in nature. The approach to solve that problem will be uh, different than the earlier ones. Voice is low. Is it for everyone? Okay, let's continue then. Some background noise. Okay, just 1 second. Is it okay now? Okay, fine. So today we'll again we'll see, we'll study the sorting problem, but we'll see a different algorithm. Then the algorithm is known as merge sort. So let me just give you the idea of this process itself. Suppose we are interested in sorting this number. Right? These 8 numbers I'm interested in sorting. So what I'll do is, instead of sorting this number, uh, all these numbers together, I'll break this problem in some smaller subproblems. Right? So what is my problem? My problem is to sort n numbers. Right? Now, what could be a smaller problem? I'll break this up into two pieces. Like I'll consider the 4 numbers from the beginning and the remaining 4 numbers. Now, my goal would be to sort these set of numbers, and after that we are going to sort these set of numbers, right? And how we are going to sort these numbers? See that this is a problem of sorting n numbers. I'm talking in terms of n. For this example, n is 8. Right? Now, what are these problems? These are basically smaller problems. Right? What do you mean by smaller? Smaller in terms of the input size. Right? Now in the next level, my problem is I need to sort this set of 2 sets of n by 2 numbers. Right? Now, how we are going to sort it? That's the question. We are going to sort this one by any kind of recursive process. So now at this point, I hope that everyone knows what do I mean by a recursive process. Can anyone tell me what is a recursive process? Yes, it's basically a function that calls itself, right? So basically, if you see that we are in this one, in the first level, we suppose we write some function for sorting n numbers, right? And at this step, we are not going to use any different algorithm for sorting the smaller subproblem. Right? Rather, we'll use the same merge sort for sorting this number. But this time, my problem size is smaller. Right? So, uh, what I should do in this case? Like, I'll say just simply, I'll say apply merge sort in this subarray itself. That's what. Okay. Now, if I go down the line, then if I again apply merge sort here, so this I should be treating as again smaller subarrays, like it will be 7 and then 12, right? And then this will be 9 and 3, right? And now this again will be treated as a single one. And now what would happen? At this point, these are single elements. So single elements we can think of, they are already been sorted. Right? If I consider only this part of this array, then this is just a single number. And the one number is already, I can assume it's sorted. Right? Now, this part is sorted, this part is sorted. Now, here's the come of getting or combining the solution of the smaller subproblems. Right? What do we mean by that? So this is a solution of the smaller subproblem. This is a solution of the smaller subproblem. My goal is to solve this one. So I'll combine the solution of these smaller subproblems to get a solution of the bigger problem. Right? So in this example, this is trivial. So I'll just say this is the sorted order of these two numbers, right? But here I'll have, in this case, I'll have 3, and then I'll have, 9 and then 3. Now, how do I combine these two? These will be the opposite of this, right? So now this is the solution of sorting this set of numbers. This is the solution of sorting this set of numbers, right? Now, how do you, so now what is my next goal? My next goal is to get a sorted order of these set of numbers. And how do I get it? That I'll get it from the solution of this subproblem and this subproblem. And at this point, I know what are the solutions of these subproblems. That are basically this one and this one. Now, what do I have to do? At this point, I have to combine these two sorted array and make it a bigger sorted array. Something like this, right? So for this example, so I'll go in details of this particular part, how to combine two sorted arrays into another sorted array. But at this point, uh, let's uh, let's assume that we just we can do it, right? And so that we can focus on this process of merge sort itself. Okay. So what would be the sorted order of these numbers? 3 will come first, and then 7, and then 9, and then 12. Right? Okay. Uh, and then this part will again be done similar. This will be divided. Again, these will be divided further. I'm not writing, but so after that, these two will be combined, and then these will be combined to get the solution. And this would be the solution of uh, this particular subproblem. And what do I mean by solution of this subproblem? That is the sorted order of these numbers. What is the sorted order of this number? It's like, I know, 1, 3, 5, and 6. Okay. And then what would be the next step? Next step would be get a solution of the outermost array. Right? So I have to now, at this point, I have to combine this sorted array and this sorted array to get a bigger sorted array. Right? So what is the sorted order of this of these two arrays? If I combine them together, so first comes this 1, And so do I have two threes? Yes, I have two threes here. So I can have any one of these two threes, right? And then I have 5, and then 6, and then 7, 9, 12, right? Okay. So this is the sorted array that I'll get. And remember that all these intermediate steps that I have done here, this is nothing but a recursive process. Okay. Now, how do I write the pseudocode of this one, of this uh, merge sort process? This is nothing but the merge sort algorithm. Okay. So, what is my first step? Step one. My first step. So, in this first step, I'll divide this array. Okay. Case of how to sort. Yes. So this, as I said, this part here, how to get this sorted array from two smaller sorted arrays, that I'll cover later. Um, yes. So what would happen if I have, in this example, I have even number of elements, or not just even, to be precise, I have 2 to the power some k many elements. For this example, I have these many elements. Right. So that's why you'll see that each time we'll have one. But that is not a very big problem, because if I have odd number of elements, I'll not get exactly equal halves, but one half will be having just one more element than the other, right? The example that you put here, it's 7, 9, and 11. So what I'll do, I'll break this up into, let's say, 7 and 9 in one part and 11 in other part, right? I'll break it in that way. So 11 is a single number, it's still 11, but here it's 7 and 9, right? While solving it recursively. So if I combine them together, so I'll have 7, 9, and then this one will be as it is 11, and then when I combine these two together, I'll get 7, 9, and 11. Right? So the point is, like, I'll break it as I'm saying, although I'm saying it, I'll divide it into equal halves, but not exactly equal. I'll say roughly equal. So what's the first step? Divide the array A into two roughly equal parts. So I'll call them, let's say I'll call them left subarray and the right subarray. Okay. So why I am, I think it's clear now why, what do I mean by roughly equal, right? If I have odd number of elements, one half will get one extra element than the other. Okay. What is the next step? What I'll do, uh, I, the next step, I'll not be, while writing the pseudocode, I'll not be writing that the left subpart will again be subdivided into two parts, and then each of the other even smaller subarrays will be again further subdivided. No, I'll not write it in this way. What I'll say, just one line I'll write that I'm going to sort this left subarray recursively. That means the whole process. Solving this left subarray recursively means that I'm going from here to here. And what is the process that I'm using? The same process of merge sort. Okay? So for this one, I'll write that sort the left subarray of A recursively. Right? And let me name it the sorted array. After sorting the subarray that I'll get is the, I'll name it as C. Okay. Step 3 is also similar. I have to sort the right subarray. Sort the right subarray recursively. Okay. And this fourth step, I'll so what have I done so far? So we are at this point. So I know the sorted order of the left subarray and I know the sorted order of the right subarray. Right? So I'll let me just write it and then I'll explain it to you. Merge the two sorted arrays. Right? C and D to get the larger sorted array. Uh, okay, so this step I need to explain in details, but somehow for the timing, as you said, like just assume that you can do it. Then whatever I have written here, this is the whole merge sort process. In this merge sort process, you are using as a function merging two sorted arrays. You are using this as a function. Is this okay? Any questions till this point? How to merge two sorted? Yes, I'll explain. As I said, I'll explain. Right? Okay. So if this part is clear, then I'll move to the details of step 4. Okay, fine. So let me now right, so let me now explain this uh, step 4 in details. Right? So let me consider this particular example here. Let's see if I can copy it. Oops, sorry. Let's move this. Okay, these are the sorted arrays that we have. After step 3, this is the situation that we have. Right? Now, I need to, so what are the names that I have given to it? This is the C array, this is the D array. Right? So, I'll assume that uh, these arrays are of some certain size, right? And then I'll uh, assume that they are of half the size. The original size will be, say, n. Okay. We'll assume this like uh, size of each is n by 2. Right? It's not always n by 2. I can say it's a L by 2. I'll say, let's say L by 2. Why I'm saying it's L by 2 is because if you consider the last step, then only it's this size is n by 2, this size is n by 2. Now, if you consider this step, this is again step 4, right? But here my sizes are smaller. Right? This is a size 1, this is a size 1, and this is 1. So it's a size, so this is L by 2, I'll say this is L by 2, this is L by 2, and this is L. Right? For the same reason, so this is L by 2, this is L by 2, this is L. Right? Again, I'll while consider this merging step, I'll consider this is L by 2, this is L by 2, this is L. Right? So actually, when you are at the last step, this is nothing but the n by 2 and n. Okay. Right? So I'm assuming their sizes are L by 2. So my new subarray, this one will be of size L. Okay. So now I need to first fix what will be the value at this subarray. Sorry, what is the first member of this sorted array? So this will again be a sorted array. Now, what will be the first member of this array B? How do you get that number? So I know for this figure, I know this will be 1, but what is so special about 1? It's the smallest, right? It's the smallest. Or suppose, let's say, like, let me put the same question here in slightly different form. Let's say this is the C array, C1, C2, C3, C4, and this is the D array. This is D1, D2, D3, D4. What are these numbers? Like these are some number, right? So CIs and DIs are some number. Right? Now, so these are sorted. Like this C and D, this is sorted. This is also sorted. Right? Can you tell me when I'm going to combine these two into a single sorted order, what will be the first element here? Yes, exactly. It will be the option for this first element will be either this one, C1, or this D1. Why? Because all the other elements are smaller than this C1 and all the other DIs are smaller than this D1. So the smallest of all of this will be the smaller of these two, and that I'll put here. Okay. And to do this, I will maintain some indices for this. So to fill up this array B, I'll use this index J, or sorry, I'll use this index K here, right? And for this C array, I'll use this index I, and for this one, I'll use this index J. Right? So in this terms, like I, J, and K, let me remove this part. I think so what we have just seen that EK will be minimum of, can you say in terms of IJ, minimum of IJ, minimum IJ, not exactly, minimum of CI and DJ. Right? This will be the right minimum of CI and DJ. So with this example, so I have 1 in here. Right? Now when I put 1 in here, so this element is gone now. So I will update my J here. So I'll move J to this one. Okay. So now again I'll have the same thing. So now at this point I have to figure out what is the element that should be present in the second place of this new B array. Again, if you see carefully, that's going to be the minimum of Ci and Dj. Again, the same thing. Right? So in this example, it's like both of them are 3. So I can take any one of them. So let's assume that I'm taking like this 3 is coming from this D array. Basically, this 3 I'm putting it here. Okay. So what should I do? I'll be having 3 here, and again, since this element is coming from this D array, I'll increase the index of J. Next comparison, minimum of C0 and D1. Okay. So you like it's the same as minimum of CIDJ, right? Correct. So then again for the next one, CI and DJ, BK. Oh, sorry, by the way. So I have to keep incrementing this K as well. Okay? BK, so that I can always write BK is equal to minimum of CI and DJ. So again, if I see what's the thing, it will be 3. Next element will be 3. Right? So what I should be doing next? Which index I should update? I should update J, sorry, I and K. Right? So again, so BK is minimum of CI and DJ. In this case, this is 5. So I'll be updating this J and K. So this will be my K, this will be J. So again, minimum of CI and DJ is 6. So this has gone now. So see something interesting happening here. J is now beyond L by 2. J is more than L by 2 now. So at this point, I know for sure what will be the remaining elements of the B array. Can you see? So all the elements of D I have put in this B array. So whatever remaining, this whole thing will get copied in here. Right? So do you all agree with this? At this point, I need there's no comparison needed at all. So I can directly write that it is going to be 7, 9, and 12. That's it. Yes, that I can write because this C array is sorted. Clear? Any questions? Okay, fine. So now just so the things will be concrete when I write the pseudocode for this one again. So I'll name this function merging of two arrays, like merge C and D. If L is odd, okay, no harm in it, but in that case, it's not always going to be L by 2, L by 2. It will be something like this. Uh, do you know what do I mean by these notations? Suppose L is 5. What is this? This is, so these are called float function and ceiling function. This one is float function. So it's just the maximum natural number less than 5 by 2. That's 2. And what's the ceiling of this? This is the minimum natural number that's just less than this. Then that's greater than this. So it's 3. Okay? So I'll not be writing this L by 2, L by 2. In that case, I'll be writing L by 2 floor and L by 2 ceiling. But that is not at all a big deal. Because just they differ by just a one number. Again, I can say roughly they are of half size. Okay. Okay. So let's write this one. So I'll assume that so I is 1, j is 1, and k is also 1. Suppose I'm putting them with indices 1, and sizes I have assumed that they are all half the sizes. Okay? And this initialization will depend on uh, at which stage are you in the merge sort. Okay. So what I'll do, I'll use a while loop for doing this. While I and j both less than L by 2. So both of them are less than L by 2. Right? That means like I and j are within this C array and D array. Right? So what I'll be doing, if Ci is less than Dj, right? So minimum of Ci and Dj is Ci. That's what we're saying. So what I'll be doing, I'll be writing Bk as Ci, okay, and I'll increment this I, okay, and if Dj is the minimum between Ci and Dj, then I'll do just the opposite of this. Bk will be Dj, and I'll be incrementing the counter of j, and after that I will be incrementing k as well. Yes, this is fine. So this is what this while loop will do. Is this clear? What if array too big, then how we make sure that what should I compare Ci? See, my argument does not depend on the size itself. That's why I have taken I and j. I and j can be anything. Starting from, I'm assuming them, they have started with 1. That can be any number. I keep on comparing them, Ci and Dj. Then there's no harm in it. So at the end, how many numbers are we going to put there in the B array? It's the size of this B array will be the number of elements here plus the number of elements in here. At most, we are going to do it for those many elements. Yes, so if both of them, both I and j, are less than the size of this D array and C array, then we do this. Is there anything else? So, for example, the case here, like when this is a case when j is getting out of the range of D. So at this point, j is more than L by 2. So this loop will not going to be executed. So in this loop, what we are saying here, both I and j should be less than L by 2. Now, if j is beyond L by 2, that means I is less than L by 2. Okay? If j is here, so then I must be less than L by 2. Okay, so I'll write that case here. While only I is less than L by 2, then what we do? Then, as I said, I don't have to care. I don't care about any elements in D, right? I'll copy all the elements of C in the array B. So what I'll be writing, Bk will be Ci, and then I'll increment both I and k, right? And that can happen in the other way also. It might happen that I goes beyond L by 2, but j remains somewhere less than L by 2, right? So in that case, we'll have just the opposite of this. So while j is less than L by 2, I'll say BK has to be DJ, and I have to increment J, and I'll also increment K as well. Okay. This is the whole merging step. Any question about this? What if either I equal to L by 2? It doesn't matter. If it's equal, then also it's okay. Okay. So why you take ij k equal to 1? So, I mean, what else you would like to take? Okay, so you might be thinking you can start with 0, like indexing starting with 0, is it? I can take 0 as well, starting index. Yes, I mean, just to like the way I was writing C1, C2, C3, C4, and D1, D2, D3, D4. For that reason, I have just put all of them initially with 1, right? But there's no harm if you start with 0 as well. As to 1. Sir, the last two while loop, what do they do? Okay, so last two while loops here, uh, this is the situation when all the elements of the D array has already been copied in B array, but you are left with few elements in the C array. Okay, this is the situation. And what is this situation? In the last while loop, you have copied all the elements of C array in the B array, but few elements of the D array still remains, and you just copy all of those elements in B array. That's the situation. The point here is to note that if this is the case, then this will not happen. And similarly, if this is not the case, this might happen. Okay, both of these last two while loops cannot occur simultaneously. Okay. Okay, fine. So you have understood this process of merge sort. But just a suggestion, if you still don't feel of understanding or not, but just you can take a few example and run it through. If Ci is equal to Dj, there is no condition for this. Basically, you can start indexing even 2 or 3. Yes, you can start your indexing with 2 or 3 even. It really depends on what is the array that you are confirming. Like, let's say we consider this portion of this array. Right? If we are starting the indices from 0, suppose this in this A array, we are starting with 0, 1, 2, 3 like this, right? And in this step, what is the subarray indices? Indices of the subarray. So this index is 2, 3. This is 0, this is 1. Right? So this subarray is from 0 to 1. This subarray is from 2 to 3. Whereas this subarray will be 4 to 5. This one will be 6 to 7. Right? Okay. So these indices you can, but once you understand this process, that I think those indices you can handle on your own. Okay. Yeah, what's the other question? If Ci is equal to Tj, there is no condition for this. Ci is equal to Dj. Oh, okay, okay, I understand. So you can do it this way. So if both of them are equal, so let's assume that I'll consider it from the Ci. Okay. So as the case happened in here, right? So both in the both of these arrays, I have 3 and 3. So I can take any one of them. Yes, correct. So I should be writing it equally. Okay. Now let's analyze this process. So what is this process? This process is correct or not? First, we have to argue it. Argue that. Then, okay. So what is the guarantee that this process will give you the correct sorted order of the input? See, again, this is a divide and conquer approach. Sorry, I'll say that what is this divide and conquer approach in a moment. But this one is like we are applying merge sort in a smaller subarray in step 2 and 3. Now, I'm going to prove this correctness again using induction. So I'll assume that for any value less than k, I can this merge sort process can sort correctly an array of size lesser or equal to k. Now, when I'm going to sort array of size k plus 1, then what's the first step? I have to divide it into two parts. Okay? And each of these smaller subarrays are of size less than k. So by induction hypothesis, I can assume that these are sorted. Right? And the only step I have to justify is this step 4. What I have to argue that in step 4, we are actually, while merging two sorted arrays, we are actually creating a larger sorted array. Right? This step I have to just justify. And this justification is fairly simple from this step itself and the thing that you have pointed out. Both C and D are sorted. So the element here, the element Bk at any point for any k, right? That element has to be the minimum of Ci and Dj. Otherwise, this there you can find some element which is less than this minimum of Ci and Dj. You can contradict that E or D is not the sorted order. Okay. So this correctness can be proved using mathematical induction, right? But the much more interesting thing that we'll study now is the running time of this merge sort. Running time of this merge sort. So this is a recursive process, and the running time of this process will do it. Will calculate it in slightly different way. We're not going to. So since in this pseudocode you can see, like, I'm not writing any for loop. You do it that and do that and uh, the other things, like what are the steps that we're going to follow. Rather than that, we'll again this process is recursive, and I will express the running time of this process again in by a recursive formula. Okay, so since this process, let me repeat again. So since this process is recursive, I'll get the running time of this process by some recursive formula. We derive uh, recursive formula for the running time. Um, my voice is low again. Is it? What about the others? Like, is it okay? Okay, okay, fine. So uh, then maybe Kishan, it's a problem from your end. Okay, so how to do it? So first we'll define something. I'll say Tn. What is this? Tn is the merge sort algorithm when applied on a set of n numbers. N for loop and log n for binary search and log n for loop and log n for binary search